Namaskar and good morning to everybody here. Before I start with the talk, I would like to thank Professor Dalila and her team for inviting us here and giving us the opportunity to get interaction with the people and scientists and researchers over here. The talk of the title of my talk is Green Bioabsorbents for Separation of Petroleum Fraction Water Emulsions in petroleum industries and applications in other sectors also. The contents of my talk will be brief introduction about the superabsorbents, role of superabsorbents in different fields like petroleum industries, biomedical, self-healing materials, agriculture, and to study their eco-friendliness. So, smart materials, they are three-dimensional materials and they consist of hydrophilic cross-linked macromolecules. We call them as smart materials also because they can respond to different stimuli like temperature, pH, light, magnetic and electric fields, ionic factors and biomolecules, etc., etc. They have got a lot of characteristics like high tensile strength, they are biodegradable in nature, they can retain the structural integrity, that's the beauty of these materials, and a lot of chemical diversity, excellent biocompatibility. Because of excellent biocompatibility, they can be used in biomedicals, and high permeability and viscoelasticity. See, the beautiful behavior of these materials, how sensitive they are towards the pH. And we find a very good pulsatile behavior under different acidic and basic pH levels. And at the same time, you will find that they are highly sensitive toward the ionic character of the salts and concentration of the salts. And this is the work being carried out in our own labs. See, the salt concentration behavior or sensitivity of such materials to different types of salts and their ionic characters. And keeping in view these characteristics of these materials, these biopolymers can be used as a sustainable solution for the removal of or separation of oil and water and for the removal of oil from the oceans so as to maintain the eco-friendliness of the oceans for the aquatic life. You see, natural oil seepage around more than 18 million gallons every year, and it spoils drastically the aquatic and terrestrial life. It disrupts the photosynthesis and traps the aquatic life and causes a lot of trouble to the food chain. So, how biopolymer technology works here? Does it through a removal of the oils and contamination they remove, and they are highly biodegradable in their nature. And when we use such materials, the ecosystem can regain or regenerate itself automatically without producing any secondary pollution. So this way, these biopolymers are around, they are efficient and they can remove about 90% of the oil from the oceans and they can clean up the oil spill, and they are highly biodegradable in nature without causing any harm to the ecology of the oceans. So in our work, we have and followed two approaches. These are two complementary approaches. The first approach was, sorry, yeah, first approach which we used, we prepared the hydrophilic polymers. And these hydrophilic polymers, they are crucial for the refining petroleum industries. And second approach we followed was to prepare the hydrophobic polymers which are crucial for the oil spill cleanup in the oceans. And here we use the xylem. And xylem we can call as nature's water magnets, and it's a hydrocarbon in nature, high polymer weight. And the method, three pathways we used here: in air synthesis, vacuum synthesis, and gamma radiation synthesis. The material used, the backbone was xylem, and the polyacrylamide chains were grafted over it, and KPS and HMTA was used as the initiator process in the system here. So, the optimized parameters were initiator concentration, reaction conditions, monomer loading, and cross-linker amount. So, these are the different reaction parameters which we could optimize during the reactions to get maximum absorption, or you can say the absorption capacity of the polymers. Remarkable water uptake performance here was that the material which we prepared under the impact of gamma radiations, followed by vacuum synthesis, and then standard method in air. And these are the results of my own lab, and you find yourself, we use different emulsions like petroleum ether and other kerosene ether, diesel water, and other petroleum fraction water emulsions. And these are different, some of the results which we got during the experimentation, and we got very good results, and very effectively we could separate different petroleum fraction water emulsion fractions. So, key performance factors here were time effect, temperature optimization, pH sensitivity, and salinity impact on the separation of petroleum fraction oil and water emulsions. And we found that the efficiency decreased by 50 to 70% when we use 15% NaCl solution, and where the efficiency was totally decreased. And at the same time, we prepared hydrophobic materials so that we could use that for the removal of oil spills from the oceans. The material used here was purified acrylic and matte methyl acrylic were used as the materials or grafted over the coconut husk, and we got very good results here. Wonderful results were obtained, and better results were obtained with the grafting of EHA, poly-EHA over the coconut husk, followed by polyamine chains over the coconut husk. So this was the method used for the separation of diesel water fractions from each other, and we got the wonderful results over here that I will show you here. And we studied the impact of NB, 2% NB and other higher percentage NB over the impact of removal of diesel fraction from the diesel water emulsions, and we found that 2% and then using this acrylamide was more impact rather higher concentration of NB. Similar results were obtained with another case, and you find that we got better results with 2% NB here in the case of grafting of polyamine chains over the silent coconut husk. And we also studied the impact of temperature and the time for the separation of different oil fractions using this hydrophobic material, and we got better results with the petroleum at 30-degree temperature. So these materials can be recycled up to 6 times. You can see yourself, and they are highly effective in the cleanup of the oil fractions from the water, and characterization was carried out, and you will find the shift in the peak for the CO group and COH group, and OH shift was observed, which clearly shows that grafting was there over the backbone. And we also did some images, and some images clearly showed the porosity of the materials, which are essential for the oil absorption capacity of the materials. Exceptional absorption performance was observed with diesel in both the cases. In case of grafting of poly-EHA over the coconut husk, and grafting of poly-MA change over the coconut husk in comparison piston. And with diesel, we got the maximum results, or you can say better results. So this is the graph, and where diesel is showing better absorbency rather than petrol, water, toluene water, and petroleum ether water emulsions. So here green chemistry for cleaner futures. We can prepare the materials and eco-friendly materials which can be used very effectively in petroleum industries, and they can also be used for the cleanup of the oil spills in the oceans. In addition, these materials can be used in different fields, including biomedicals, agrochemicals, tissue engineering, and so on. So let's have the example of controlled release of drugs. They can be used very efficiently for the controlled release of drugs. For example, why we should go for such materials for the controlled release of drugs? Why not to follow the traditional methods? I will give you the example of this dopamine. If you take the dopamine, you know, deficiency of dopamine, it causes a Parkinson's disease. And if you take the dopamine as such, it will switch on all the dopamine receptors in the body and will cause a lot of side effects. But if the same dopamine is given at the desired site to such material in a controlled manner, no side effects will take place. Similarly, you see here, anti-carcinogenic drug, anti-cancer drug. This drug is highly efficient. It can kill the carcinogenic cells. But this drug is not in a position to differentiate between the good and bad cells. If you give this drug to the traditional methods, it will damage the good cells also and will have a lot of side effects. And here also you will find another example, food-drug interactions. If you take the tetracycline, it forms a very good complex with the calcium. You cannot take calcium-rich food or drinks immediately after taking the tetracycline. Why? Because it will form a complex, and that complex cannot be easily broken, and absorption of that tetracycline will not be there. Similarly, you will find the drug-drug interactions. Cholestyramine, if taken along with warfarin and thyroxine, they will interact with each other. So, instead of going for traditional way of taking the medicines, drugs, if you follow the control release of drug system, we are always on safer side. We can avoid or minimize the side effects. And such materials here, they are playing very important role. Other biomedical applications, say cell filling. It's a natural phenomenon in our body. If there is an injury, our body gets healed up after some time automatically. So the question is, can we prepare such material in our lab? Yes, we can prepare such materials in the lab. Here the constitutional dynamic chemistry plays very important role. Different types of bondings. Primary bonding and secondary bonding, they are operating simultaneously. You will find here non-covalent bonds and covalent bonds. Breaking of bonds, formation of new bonds are there, and self-healing process automatically goes on. And this is the work which is being carried out in my own lab. We are preparing such self-healing materials in the lab. And you will find here how different types of bonds they are being formed. And when you break it into two parts, again reformation of bonds takes place and self-healing automatically takes place. Yeah, similarly here also, mechanism, how it operates. Yeah, you see here hydrogen bonding, molecular addition, ship-based formation, etc., etc. They are operating simultaneously and self-healing of the materials takes place. So these are all the studies which are being carried out in my own lab at NIT Jalandhar, India. Yeah, all these studies are being carried out in our own labs, and these are our own results, and we could very successfully prepare the self-healing materials in our labs. All our own results, and we studied their degradation behavior at different pH levels in phosphate buffer and in urea also. How stable they are at different pH and different media. That's very important. We studied all these things, and we found they are quite stable up to 5-6 hours. Other application was, can these materials be useful? Can biomaterials be useful in agriculture sector or not? Yes, they are highly useful. How they are? Let me show you. They can be used for the conservation of moisture in the soil. They can prove to be a boon to the agriculture sector, and they can act as mini water reservoirs in the soil. And we have used such material, we have prepared the materials and used them for the conservation of moisture in the soil, and we were highly successful. Here we use 3 types of soils: clay soil, sandy soil, and the mix of 2. And we got very good results here. You will find very good results for obtaining. We could get the moisture retention in the soil for a longer period by use of such materials. Say, this is the table of form, this is the control, and these are the materials which we prepared in our lab, and we could conserve the moisture in the soil for a very long time. That was the beauty of such materials, and such materials can be used in drought-ridden areas. Yes, next point here was, can such material be used for the controlled release of fertilizers to the plants or not? Yes, the answer here is yes. They are highly eco-friendly in nature. Here in our study we used the black plants, and we found very wonderful results here. Before going to our results, let me tell you why we should use such materials for the controlled release of fertilizers. Why? What's the need? The need here is, after effects of green revolution. You say after green revolution, a lot of side effects are there. People are not eating grains, they are eating the chemicals. They are drinking chemicals. This is a problem all over the world. High water solubility of fertilizer. The fertilizers are highly soluble in water. They go deep into the underground water and cause a lot of contamination of the water, and have a lot of side effects. And rising cost of the fertilizer because you have to see the economy of the farmers also. And here through controlled lease, we are very highly economical. And increasing BOD and COD levels, we have to decrease the BOD and COD levels in the aqueous medium. And the main problem is with eutrophication and biomagnification, which is a lot of hazards to the aquatic life and other lives. And you will find here the sustainable use of fertilizer is very important for the economy of the farmers, for the ecosystem, and for the safety of life on this planet Earth. So in our lab, we prepared the vermicompost biofertilizer, and that vermicompost biofertilizer was given in a controlled manner for material to the plants. And here we use three types of sets. One is negative control, that is positive control, and this is the test samples. In negative control, we have not given anything. In positive control, we have given directly the fertilizer to the plant. And in our test samples, we have delivered the fertilizer to the plants in a controlled manner to the material which we have prepared in the lab. And you find that, say here, better results were with the controlled release of the fertilizers. That's the beauty of the results. These are all results of our lab. Similarly, let me give a little introduction about the nodules in the plants. These are required for the symbiotic association between the plant and the rhizobium bacteria. They are used for the fixation of nitrogen from the atmosphere in the soil, and that nitrogen is required for the vegetative growth of the plants. And in our results in the lab, we found beautiful nodules to the controlled release of fertilizer to the materials. And these nodules, that's why the vegetative growth was better in case of the controlled release as compared to negative and positive control. These are the results in table form. You find here the results for negative control, positive control, and these are our on samples. And we measured the short length, root length, fresh plant weight, and dry plant weight, and we got better results with the controlled release. Similarly, we also did the controlled delivery of urea fertilizer to the plants, and we got better results with the controlled release. Yeah. So, you find here the better results with the control release of the fertilizer through our own device, which we prepared in the laboratory. Here also, we release potassium nitrate, one of the fertilizers, to the plants with our controlled device, and we found better results. Next point is, are these materials biodegradable in nature? Are they eco-friendly? Are they causing any harm to the nature or not? We study the biodegradation behavior under different conditions like soil burial method, composting method, and vermicomposting method. And we found that these materials, they are highly biodegradable within 60 to 70 days. That clearly shows they are eco-friendly in nature. Yeah, these are results for the composting, decomposition, biodegradation, and these are results for vermicomposting, biodegradation of such materials. The next point was, is there any impact of that biodegradation of such materials on the soil fertility or not? The answer is no. They are biodegradable in the soil and they are not causing any adverse impact on the health of the soil. That study we carried out in our lab. You will find here, these are the test samples. This is the control sample, simple soil, and we got better plant growth in the soil where the biodegradation of such materials was carried out. And you can yourself see here, the studies were carried out for about 28 days. This is the control, simple soil and garden soil you can say, and these are the soils where the such materials were degraded and then plant growth was taken place. And you further went to see whether there is any impact on the chemical characteristics or physical characteristics of the soil or not. We did the micro analysis of the soil. We studied the pH, electrical conductivity, organic carbon, phosphorus in the soil and potassium in the soil. And this is a control soil, garden soil, which was taken as a control, and these are the materials which were degraded in the soil for biodegradation purpose, and you will find the results are almost near to the parameters for the garden soil. It clearly shows that there was no adverse impact on the health of the soil by the degradation of, through the degradation of these materials in the soil. So, now I am coming to the conclusion. Such materials play an important role in different fields and they can respond to different stimuli. That's why we call them as smart materials, and they are of great importance in petroleum industries, oil spill cleaning, and they are of great importance in biomedicals because these materials, they behave like natural tissues. They can retain a large volume of water like our own tissues, because you know our body retains around 70% of water. Similarly, these materials, they can retain a very large amount of water and they can retain the structural integrity. They don't get disintegrated. They can retain the structural integrity like our own tissues. That's why they are highly used in biomedicals, and they are highly biocompatible in nature with least toxic effects. They are eco-friendly in nature and they can effectively be used in agro sectors. They can be used as mini water reservoirs and they can be effectively used for the controlled release of fertilizer in an eco-friendly manner to the plants without causing any eutrophication and biomagnification impacts. This is how the journey of smart material it started with biomedicals initially during 1960s, where the contact lenses were prepared, and slowly now it is being used in different sectors like petroleum industries, oil spill cleaning, agriculture sectors, along with other sectors. Say here, he is a traditional farmer who is not knowing anything about the advancement in polymer science and technology, and this is a smart fiber who is well aware about the advancement in science, polymer science and technology, and is making effective use of the technology. That's why he is more prosperous than the traditional farmer. Yes, I am highly thankful to my institute for giving me all kinds of facilities for carrying out the such studies, and I am also thankful to my research group. Because of my research group, I am here and presenting my work in front of you people. It's because it's their work. In fact, they are working day and night in the labs, and I am highly thankful to my research group. And this is my institute. That's the National Institute of Technology, Jalandhar. This is an institute of national importance by Act of Parliament 2007, Government of India. And here, we have got all kinds of facilities where we have got very advanced labs there, advanced equipment facilities are there. And it's the institute of central government. We are getting a lot of fundings also for carrying out such R&D activities and patenting, etc. Thank you. Jai Hind, Jai Bharat.